Good afternoon and welcome everybody. Thank you for taking time to come to this webinar today. With quite a bit of interest. We've got, I think, over 100 attending at the moment and over 300 tickets sold. So there's obviously a lot more interest than we expected for this topic. So the webinar today is dealing with retrofitting your home, specifically to the BER B2 or better. So we will do with or better quite a lot. Just to introduce myself, my name is Mel Gavin. I work for IT Sligo in the Contract Research Unit. Our unit is an outward-facing support unit working with SMEs, communities and individuals. We're part of the research department there, but all our work is external. As part of our role, one of our jobs is to work as mentors and coordinators for SEAI on the Sustainable Energy Communities programme, and we work in the Border and West Counties. I'm joined by my own team here today by Steve Donnelly and Paul McNamara. So Paul is handling the technical issues primarily, and Stevie is going to help out with the questions as well. I'll introduce the speakers in a moment, but just to let you know, we are recording this event, and we will send out a link to a YouTube video at a later date. We'll send it out to everybody who's registered. So you don't need to worry too much about trying to remember everything or trying to take notes. We'll also send the slides with that email as well. Okay. So we're 6 minutes past our starting time, so we will move on. Okay. So just a quick overview. I'm going to talk a little bit about the background on the BER B2 because it's become a target now. It's enshrined in the Climate Action Plan, and it's had an impact on grant schemes and things like that. We then will move on to probably the more interesting part of the overall presentation, which is the practical examples. So we have three industry experts with us today. I'll introduce them in more detail in a moment, and they're going to go through examples of works they've completed recently on homes. So you'll see the measures that they put in and the kind of uplift each measure achieved on the homes, and getting up to B2 and beyond. And then we'll have a question and answer session. Now, it's not realistic to have open mic question and answers on a webinar with this many attendees. So on your screen, you will see a Q&A function. If you put your questions in there, we'll address them at the Q&A section. Unfortunately, we're not likely to be able to get to everybody's questions, so we're going to select some. Myself and Stevie and Paul will select some to be answered. And in the email that we send out afterwards, we will try to answer everybody's questions. It probably won't be possible or feasible to do that, but we will try. In any event, there are a number of these webinars coming up, not just done by us, so there will be more chances to get the information you need. Okay, so I'm just going to introduce the speakers. So we have Pat Lavin from EcoSmart. They're an energy retrofitting company. They specialise in external wall insulation, but they do the full package of works. So you have architects and designers in that company. They're based in Castlereagh, County Roscommon, but they also have a warehouse in Dublin, and they provide a nationwide service. They've been BEC project coordinators working with Clor ICH a lot in the west of Ireland and throughout Ireland. So Pat will be our first speaker. We'll follow that then with Neil Walsh from First Rate Energy Services. So they are a company of BER assessors, heat pump technical assessors and energy consultants. So Neil also works regularly with Midland Warmer Homes. And the final speaker today is David Flannery of Super Homes. Now, Super Homes is a project initiative started by Tipperary Energy Agency. So they specialise in taking homes through to deep retrofit. So Neil has been a retrofit advisor there for quite some time, and they've worked on over 250 deep retrofit projects in the last 3 to 4 years. So I'll quickly bore everyone with the policy background. It starts here with the building regulations that were updated in November 2019. So the Part L of the building regulations deals with energy performance. And in part, in that revision in 2019, For existing buildings, a major renovation was a classification that was added there. A major renovation is considered where you have more than 25% of the surface of the building envelope undergoing works. Now, the surface is essentially the thermal envelope, so your ground floor, your walls, windows, doors, and roof. So if you're doing work to 25% or more, that may be considered major renovation. If it is a major renovation, then you have to take the energy performance of the building up to this cost optimal level. But the building regulations does accept that that's not always feasible, either technically, functionally, or economically. Also, some works that you might be doing on the outside walls or roofs of your house, they're not considered major renovation. They include simple things like painting and plastering, but probably more importantly to talk about today is your cavity wall insulation, so pumped insulation and your attic insulation. They're not considered major renovations, so you can carry on with those without impacting the building regulations. With regard to the building regulations, a major renovation tends to be activated when you're doing external wall insulation or internal wall insulation, and then you have to achieve this cost optimal level. So the first way to do that, the simplest way to do that, is for the BER of the building to be taken up to B2 or better. If that's the case, then that's it. You simply met your obligations under the building regulations. If you don't make it to B2, the building regulations will accept a cost optimal equivalent. So in this cost optimal equivalent, you have to ensure that your attic insulation and your heating systems are up to a certain standard. And if they're not up to that certain standard, then you need to upgrade them as well. And that will meet the building regulations. Now, we have a very lovely flowchart to navigate your way through this, but it is essentially as I've described in the last couple of slides. So don't try and read this now. This will go out in the slides to everybody. The B2 BER has then been enshrined in the Climate Action Plan, and one of the more tangible targets in there is to bring essentially a quarter of our existing housing stock in Ireland up to a B2 BER, or cost optimal equivalent. This has had an impact on grant schemes, as many of you on this webinar will be aware of. Any government funded works, they have to meet minimum regulations, so they cannot fund things that are not going to meet the building regulations. So for the BEC, or the community grant as it's now known, and the National Housing Retrofit Strategy, the B2 BER is the primary threshold that homes have to meet, and there is a dispensation there to meet C1, but subject to prior approval. Now that's a large nationwide multi-million euro grant scheme. So this is an efficient way to manage that scheme. Now with the individual homeowner grants, you can still avail of external wall insulation grants and internal wall insulation grants and just achieve the cost optimal equivalent works. So when you're applying for that, the ideal thing is to talk to a contractor, and they will advise you as to what you need to do, whether you need to do your attic and your heating as well to meet the building regulations and to have the grant accepted. Okay, so we're going to move on now to Pat Lavin from EcoSmart. So Pat, are you there?
Yeah, I'm here, Matt.
Okay, Pat, I'm going to bring up your first slide and then you can just tell me when you want me to move on.
Okay, perfect, thank you. Hi everybody, Pat Lavin is my name, from EcoSmart in Castlereagh in County Roscommon. If you can move on to the next slide there, Mel, please. Myself and an architect back in 2007 decided to get together to, create a company that would deal with retrofits and all the energy efficiency products that were required in the domestic market. So we set up EcoSmart at that stage. We have an engineering architectural practice as well that runs alongside EcoSmart. We're involved in the retrofit and new build works, predominantly with insulation, but also with heating systems and renewable products. We set up an energy showroom back in 08, 09, just to kind of show people what the products were like. We had a good uptake from that, and from that things have grown since. We specialise in external wall insulation. So we're in SEAI approved technical distributors for the Atlas Aval system. This is one of a number of systems that are approved in Ireland for SEAI and in SEAI to be retrofitted onto existing buildings and to be put onto new buildings. Another part of what we do are better energy community schemes, where we act as a project coordinator with Clore ICH in Claremorris. So what that involves in is pulling packages of retrofit works together. If you can move on to the next slide now, please. So those better energy community schemes are SEAI funded, and they are for existing properties only. There are different levels of funding for different parts of the projects. So commercial projects would get up to 30% funding. That would be the likes of industry, factories, shops, so on and so forth. Then you would have community projects, which would be the likes of community centres, GA clubs, all similar types of community buildings that would be able to avail of up to 50% funding. Then you have private individuals who are in receipt of fuel allowance or a similar assistance with a grant aid value of up to 80%. Again, these are all for energy efficiency only items, which would be the likes of windows and doors, insulation, renewable heating systems, PV, which is photovoltaic, and so on and so forth. Local authorities are funded at up to 35%, and housing associations are funded up to 50%. So this is where our project, or I suppose this house we're looking at today, comes from. It was funded through the Better Energy Community Scheme. So this particular project, you can move on to the next slide, Mel, please. This particular project was a domestic house, and the client was in receipt of fuel allowance. So we were able to obtain a high level of funding for them to go and get a retrofit carried out on the house. And if you want to move on to the next one, Mel, please. Pre-works, this house was a G rating. So we really had to bring it from the bottom right up to up to B2, basically. So it's a detached bungalow. It was constructed in 1965, and it has a floor area of 87 metres squared. The wall type is it's a precast concrete. They're named like RoFab. So there were precast concrete panels that were manufactured in a factory, brought to site, and the house was put up in panels. There were single glazed windows and doors throughout, and there was 100 mil of fiberglass insulation in the attic, which was basically compacted down to probably 40 or 50 mil. The existing heating system was a standard oil boiler with very little controls. It was just on and off, so there was no time and temperature or zone control on it. And there was one open fire, which was just a standard open fire with a grate in it. You can move on to the next one now, please. So we had to come up with a plan as to how we would bring the house up to the B rating. And we would always start with fabric first. So the fabric first approach would be the windows, which were in a very poor condition, needed replacing, as did the doors. In this case, we put in triple glazed windows, and we put in a standard UPVC white doors. The attic insulation, we upped the insulation to 300 mils, which gave us the current building regulations. Externally, we put 100 mil of EPS insulation onto the outside of the entire building. We installed a new condensing oil boiler, and it was fitted with time and temperature zone control. But because SEAI do not fund oil boilers or any oil or gas boilers anymore, we were only able to get funding for the controls element of the system. So this means we got some money from SEAI towards putting in a time clock, TRVs, and we put in time and temperature zone control with automation on the whole system. As a secondary heating system then into the old open fire, we put a wood burning only stove. And this needed to be in compliance with the Eco Design Directive also, which is a condition of getting the funding from SEAI. At that level, the house was approximately a C2 when we had those works done. So in order to achieve the B rating that's required, we installed 2 kilowatts of PV solar. So if you move on again to the next slide now, basically this shows the house just at the early stages when we had put in new windows and doors, and we were just getting the building ready for the external insulation. Now, those houses, because of their design, sometimes had windows that were very big or in the wrong locations, or kind of made the appearance of the house look a little bit odd. So when you are externally insulating the house, you're able to modify the structure slightly to incorporate different sizes or types of windows. The windows were located at the outside edge of the existing structure, and that gave us the opportunity to reduce the thermal bridging around the windows and doors themselves. You move to the next slide now. The next slide is the external insulation applied to the building. So this is the insulation applied, ready to receive its base coat and its reinforcing mesh. As you can see from the windows there, the window sills in place are also a thermally broken window sill. They are an EPS window sill with a resin finish on them that can be painted afterwards. These are manufactured in Cork by Passive Sills. You can move on to the next one now, please. Again, that's just another view of the same property. Now, if this property was a different wall type, we would have to look at a different system. If it was a stone building with lime render and or lime plaster and mortar, we would have to go with a Roker system, which would be a mineral wool system, which would be breathable to allow the existing building to breathe. The final photo there of the building is the finished product. That is the house with the windows and doors fitted. The heating has been upgraded. The external insulation has been applied, and the final finish is honoured with a colour pre-mixed into it. So that is a silicone render finish that's on that building. It looks like a matte plaster finish, and it's very durable, provided that you follow the manufacturer's instructions and maintain it every year. Move on to the next one now, please. So the reasons we chose each particular element to upgrade were obviously driven by the B2 rating, but they were also driven by what the house required and what was the best options for the particular homeowner. We changed the windows and doors because they were clearly in very poor condition and very, very poor thermally. Obviously, we brought the attic insulation up to the current standards. And again, this is the most cost-effective way of improving a building's thermal performance, as it is the cheapest way of insulating your home. We chose the external insulation because this particular house had no cavity wall, so therefore we were not able to boost it by putting in cavity insulation. We preferred it over dry lining as it is a lot less invasive to the homeowner. We don't need to go into the house to put in, we'll say taking off heating systems, starting to take off radiators, strip away walls and putting insulation on from the inside. We were able to do the vast majority of the work externally, except to provide ventilation. That was really the only reason we needed to go into the house. It also helped us with the aesthetics of the building, as we were able to resize the windows and make the house look more traditional. It also had the effect that we could reduce the size of the windows on the north elevation and increase them on the south elevation to give us better passive solar gain. Can we move on to the next one now, please? We chose the condensing oil boiler and the heating controls because this is all that was in the budget for this particular project. So in order for us to get it to the level it was, we had to carry out the full suite of works, the insulations, the window replacement, and so on and so forth. Now, while the client had to contribute towards it, their budget was very, very small. So we had to use a condensing oil boiler instead of putting in a heat pump. So if the budget was there, we will be saying at all stages now, if we can get the house to the HLI that's required, we would always try and put a heat pump into it. We installed a stove as a secondary heating system because it basically increased the efficiency of the secondary heating system from a very poor 30% to over 65%. The last item we installed was the PV panels. So the PV panels, we installed 2 kilowatts of PV, and really this was to get the house up to the B2 criteria, but it also works well for the homeowner. They are getting approximately a generation of €250 of electricity per year. One thing we would say about the PV is to make sure that the homeowner understands how they need to use it. There is no battery backup with this, so you need to use the electricity as it's being generated. So, for example, we would have told that homeowner to make sure to use their dryers and washing machines and any of that sort of appliances during the day when the sun was at its highest. There's an app with that particular product, and it shows you your generation and when you can actually get the most benefit from it. That's, I suppose, the whole details of that particular house. I think that's it now. Okay.
Thanks, Pat. Just wanted to, before I introduce the next speaker, just want to say thanks, Pat. And we asked Pat Lavin specifically for an example without a heat pump, because we know that it's difficult to reach the heat loss indicator for heat pumps, particularly in bungalows. It can be done, but it can be difficult. So you can see there as well some of the technical considerations around external wall insulation. Some of the improvements that can be made by reducing the window sizes and dealing with thermal bridging. So there's a lot of work done there, and it's a very good example of a home taken to that level without a heat pump. So we'll move on now to Neil Walsh of First Rate Energy Services. Neil, can you hear me? Yeah, yep. You there? Good stuff, Neil. Yep. Okay, I'll bring up your first slide and then you can just tell me when to move on.
No problem. So just who we are, First Rate Energy. Again, we were started and established around 2007 at the start of the BER being implemented into the country. We initially worked on a lot of new builds and sites at the time, but as things started closing down, we were very happy that the BERs for existing houses started in late 2008, early 2009, and it started from there, and we built that up over the years. So in towards generating more information on how to get houses up to a certain level. Even back when there wasn't major grants available, we were trying to give people an overrun of what they could do to bring their houses up and not just be doing standard BERs on houses. Again, we're nearly a nationwide operation at this stage, and we have assessors all over the country. We offer other areas of expertise in air tightness testing and thermal imaging, and we're all, as well as that, we're technical advisors, which we offer information on the SEAI heat pump grant. The next slide there, Matt. So again, we do domestic BERs for grant and rental property, and we organise commercial BERs for business premises. We have been working in conjunction with Midland Warmer Homes since around 2012, when the first of the BEC started back then, and we've been working with them ever since on their yearly projects. We've carried out loads of assessments in homes and advising customers and homeowners how to upgrade their house to B2 and beyond. The next slide there again, Matt. So for our sample house, it's very similar to Pat's. Again, it's not as old. The house was constructed in 1983. The current BER is an F rating, 387.13. The current HLI, which Pat did speak about, is 3.46. Now, the HLI is very important in terms of the grant, especially gearing towards a heat pump application. And we'll discuss that more in the next few slides. So the BER required in this house is a B2 or better. It's going to be a full retrofit of the house. It's going to be more or less gutted. And when the work is completed, we're looking to get as high a rating as possible. So the HLI required kind of comes in two folds. It can be less than 2.0 or less than 2.3, which is the updated guidance set up by SEAI. Now, the 2.3, we have to jump through a few extra hoops to satisfy the needs of the heat pump grant, but mainly we try and get our houses down to less than 2.0. And what SEAI recommend is that a house is under 2.0, it is then eligible to get the heat pump, and that the heat pump will work effectively in that house. And the heat loss of that house is at a level that it will run correctly. So the next slide down, again, as we said, the HLI is based on the total of fabric and ventilation loss for the dwelling, and it's divided by the floor area. It is calculated on the DEEP software, which is the BER software, and a DEEP assessment accurately reflects the dwelling at the time of the technical assessment. The HLI then is the total heat loss per metre squared of the dwelling floor area. The HLI requirements must be met, as we said earlier, to be entitled to a heat pump grant. This must be taken into consideration before work is commenced and the technical assessment carried out as part of the grant process. As we said there, the 2.0 automatically entitles the homeowner to apply for a heat pump grant, but the 2.3 level, which is on a lot of occasions when we cannot go in deep retrofit, where windows were replaced maybe 7 or 8 years ago, and the homeowner doesn't want to replace good standard 1.4 to 1.6, 1.9 double glazed windows. They don't want to rip up their floor. So it's up to ourselves then to try and make it work, that although we're not under 2.0, we're gaining a 2.25 or a 2.16 HLI, but we're not under the magical 2.0. And then we have to make sure that we meet the 4 elements listed below, which one would be our maximum exposed wall U value would be 0.37, which in typical terms would be a pumped cavity of about 80 mil, or a newer house was built in 2005 or 2005 onwards would have a default of 0.37. So anything that's younger or that's built before 2005 would have had to have some work done to it, or we would propose work to be done to the walls of the house at that stage. The maximum U value for a horizontal attic would be 0.16, which would be more or less 250 mil of insulation in the attic, or on a sloping section, or on a flat roof, or in an inaccessible area, then you're looking at a U value of 0.25, which in these areas are not that easy to get that U value. where a typical house built in 95 would have had a 150 mil fiberglass built in there, and that would be over 0.3435, which would be a nice bit away from the 0.25 on a sloping section on a dormer house built in 1995. Our maximum window U value is 2.8, which is a double glazed unit with at least a 12 mil gap between them. And maybe a lot of older houses built pre-98 might have a 6 mil gap between them. Now, the one sticking point that we get in houses that we get to that are between 2.0 and 2.3 is our maximum adjusted infiltration rate. And what that is the rate of infiltration that we have in relation to your ventilation processes in the house. So a house that has 2 en-suites and maybe a back toilet might have an extractor in each of them, and that would unfortunately go against that. So again, to adjust the infiltration rate and to improve that as best we can, what we'll be looking to do is get an air tightness test done on the house to see what we can achieve in relation to bringing it down below a certain value. The next slide there, Mel, please. So on the house in question, we're mainly starting off with fabric upgrade. So that's our wall insulation, roof insulation, external windows and doors, which will be composite doors and triple glazed windows. Our floor insulation, as we spoke about earlier, that it's a full retrofit of the house, and chimney and flue openings, which would be as much to do with the ventilation processes as the fabric, but it all ties in for the HLI. Next slide, Mel, please. So we're looking at the wall insulation first. So this house had a cavity wall built in 1983, and there was roughly 40 to 50 mil white board in the cavity. Now, again, we measured the cavity in a few places. At the meter box, we did a boroscope test on the house, and we could see that there was a 40 to 45 to 50 mil residual cavity that could be pumped with bonded bead. And as you can see on the diagram there, that the bead is pumped in through the external wall and pumped in between the existing insulation board and the external leaf of the blockwork. We're also adding a dry lining board, which is a 62.5 mil insulated slab, with 50 mil polyiso, which is your name of the product, your Extratherm, your Kingspan, your Ballytherm, your Quintherm, your standard 0.022 watt per meters Kelvin thermal conductivity polyiso board, and that's 50 plus the 12.5 mil slab. So the proposed U value when the wall will be pumped and the dry lining installed will be 0.2 watts per meter square Kelvin, which given the book value of the original cavity wall is 0.6, so that's a fairly good improvement on it. Now, on that measure, the BER uplift, as we seen at the start, was an F rating 387.13, and that will drop down to an E2, which is 347.49. And the HLI improvement goes from 3.46 to 3.07. So that's the starting process of the fabric. So if we move to the next slide, Mel, it'll go show the roof insulation. So again, it was a standard timber cut roof. It's no more than Pat's house. It had 100 mil fiberglass in the attic, but the attic insulation in this wasn't at a bad standard and hadn't, or else was replaced over time and it was at the top of the joist. The proposed insulation would be 200 mil fiberglass layer to be installed. The proposed U value would be 0.13 watts per meter squared Kelvin, and the BER uplift is to an E2 from an E2 347.49 to an E1 318.94. So we're making steady progress in the BER uplift, and our HLI improvement is 3.07 down to 2.8. And as Pat said previously, attic insulation in a horizontal attic like that, it's the cheapest way to drive down your BER, to drive down your HLI, and to improve the cost. Even if that small measure is done as a standalone, it's going to make a difference and it's not expensive. So the windows and door upgrades are next. So existing, we had metal aluminium windows, and they were very cold to touch. They weep in cold weather. There's condensation on them all the time, especially aluminium metal doors. And these were, even though they were double glazed, this still happened. There was a 6 mil spacer bar in between them, and they have an approximate book value of 3.7 watts per meter square Kelvin. And when you can see that today's values that some windows can be got as low as 0.65, 0.7, That's a long way off current standard. So the proposed windows installation in this house should be no more than 1.1 watts per meter square Kelvin, which would be a good standard triple glazed window. But as I always tell homeowners, my values are target, try and beat them, try and get lower than them. So again, if we could get down to below the 1.0 mark there, would be brilliant. So we're looking at our front and rear door to be composite doors with a U value of less than 1.0. And as the picture on the right hand side shows, the fact that we're going to be dry lining the house, it gives us the chance maybe to cut back the reveal a small bit, to put on an airtightness tape, to seal up around new windows properly, so that it lessens the air infiltration into the house through windows, gaps, and air movement under sills and under window boards and the like. So this will create an airtight seal around the windows during the installation. As we can see, our BER uplift has gone from an E1 to a D2, and the HLI improvement has gone significantly now, 2.8 down to 2.24, which is bringing us under the 2.3 mark. So we move on to the next slide. So in this house, the floor insulation is going to be upgraded. As we spoke about earlier, we need to get underneath that 2.3 mark. We have got there with the windows. The floor now is an additional improvement, which will probably get us under the line, as we'll see later on. So there was no insulation installed in this house when it was constructed in 1983. There is 75 mil polyiso in that will be fitted. Again, the same thermal conductivity as the dry lining insulation, no matter what standard brand you use, unless you go for the more, let's say, expensive add-ons, or there is more expensive insulation with some of the different suppliers. More or less the standard thermal conductivity for the polyiso board again is 0.022, and that will be under a new underfloor heating system and achieve a U value again of 0.2 watts per meter square Kelvin, which is very similar to the wall U value. All perimeter walls and the internal face of the internal wall, or the external walls as well, there should be enough stand perimeter insulation fitted to limit thermal bridging into the blockwork. If possible, if it can be done, this should be looked at a radon sump and a radon barrier installed while the floor is lifted. Now the BER is going from a D2 to a D1, and it's a fairly substantial gain. We're nearly at a C3, and we have now brought ourselves below the magical 2.0 HLI mark, and we've gone from 2.24 to 1.87. And the next slide, Mel, please. So the fifth element there is your chimney and flue openings. So this house had a range, an oil range, and it had 2 open fires. So the oil range is going to be removed, and one of the open fires will be blocked. There will be an insert stove then fitted to replace the remaining open fire, and I think that shows a 5 kilowatt insert stove fitted there, and the new casing and hearth around it and everything, and in place of a standard open fire. So the BER uplift then goes from the D1 to the C3. Not a massive move, but again, air losses up the chimney are massive. So again, if you can close the stove, is nearly as important when it's not working as when it is working, when it's been used. That you can close the dampers, that you can seal it up and stop massive amounts of heat escaping up an open chimney. And the HLI improves then from 1.87 to 1.81. Next slide, please, Mel. Now there is additional fabric upgrades that can be utilized to meet the HLI targets. So we would always speak to the homeowner about getting an air tightness test done, about getting the air infiltration level down as low as possible, so that there isn't unwanted cold air coming in and heat that you're generating going out. It's nearly it should be done nearly with, in my opinion, should be done with nearly every house that is worked on. It's not an expensive thing to do, and it could find somewhere and some big weakness in your house that you didn't know you had, and if that was blocked up and working and not letting that heat out, it would pay for itself in a short time altogether. The last thing that it is starting to become a lot more prevalent now in major upgrades is your mechanical heterocopy ventilation. Again, it's not part of that one there, but it's something that's coming in, and it for me personally, it's more of a lifestyle choice than an energy choice. But the fresh air in your house is imperatively important, and that there's not stale air building up in your house on these new or retrofitted houses that are well insulated, airtight, not letting air move around properly. People tell me they can control their ventilation by their windows. They're codding themselves. It's something that needs to be looked at and planned out and try to use it when you're retrofitting into a house, because again, fresh air coming into your house that's been conditioned by the air coming out and coming in at 16, 17 degrees is better than an air change through a wall or through a vent in a window and replacing your nice warm air with, as today, with maybe 4 or 5 degree air coming in. Next slide, Mel, please. So our heating upgrades, moving on from our insulation. So again, the proposed methods of heating here is to install an air-to-water heat pump to replace a 60% efficient single burner oil range. And the space heating efficiency with the sample of the 6 kilowatt air-to-water heat pump used in this house, because it has under-floor heating, is over 500% efficient, which is brilliant. And the water heating then is coming in at 321% efficient. The heating will be controlled in by programmable thermostat in each of the main rooms. What I mean by main room is that your utility room would tie in with your kitchen. Your hallway would be your area for your thermostat, would tie in a bathroom or a closet or things like that. You wouldn't have a thermostat in every room, but in a bungalow like that with 4 bedrooms, living room, kitchen, dining, you're looking at 4, 5 or 6 different zones to control your heating. So the BER uplift here is going from our C3 as we got above when the stove was installed all the way to an A2 of 48.25, which is a brilliant uplift for the house. Next slide, please, Matt. So again, there's additional grant measures that can be installed in the house. So on this one, we propose to install 10 335 watt PV panels on the southeast elevation. And the electricity generated here will help run the heat pump, and especially in daylight hours. Obviously, if there was a battery pack fitted, it could generate that to store the energy and to use it during the nighttime hours as well. And by installing the 10 PV panels, we're looking at an uplift from their RA2 to nearly 0 kilowatt hours, or 1.41. Now, again, not to be taken with a pinch of salt, but it's all how the homeowner runs their own house. But on the software, it's showing an A1 and 1.41. On conclusion, next slide, sorry, Mel, next slide, please. In conclusion, the BER changes all the way from an F of 387.13 to an A1 rating of 1.41. The HLI improves from 3.46 down to 1.81, and the BER with the heat pump is A2, and with the additional PV is A1. So the next slide, please, Matt. So if we look at the grants that are available from the Better Energy Homes grant, I'm nearly 100% sure now our figures are right here, but the main ones were the dry lining grant, 2.4, attic insulation of 400, our heat pump at 3.5, BER at 50 at the end, and our technical assessment at 200 at the start. So the total Better Energy Homes grant for this house is 6,550. The PV then it may be installed, it depends on the kilowatt it's used, but in this house, installed 3 kilowatt PV panel and battery, if there was a battery added, could have a grant up to €2,700 on top of that again, which is another nice sum of money. Now, for the BECs, the community grants, or for the natural retrofit grants, there is up to 35% available for this house, which will be an able to pay house, more so than the 80% grant that Pat mentioned earlier about the fuel poor or house. Each home requires to be assessed, and the installs would be agreed and would be priced out to meet the demand that's required in that house. Now, the grants are specifically worked around the 35% of the cost of that measure. And the works that are covered are your attic. On this house will be attic, dry lining, heat pumps, windows, doors, BER, technical assessment, heat recovery ventilation, and on occasion floor insulation. So while the for the retrofit scheme, you need to get at least 5 houses on a group to tie into this. You'd be looking at having more measures included in your application. But the main thing on the fabric application is that you get to a B2. So on a newer house, if you got to a B2 with attic, wall insulation and windows and doors, without the floor insulation and without the heat recovery, the SEAI may not give you the grant towards them if you're already at a B2. But if you're at an older house and it takes all these measures to get to a B2, then they would be recommended. So it's not an entire science in itself. It's something that needs to be a case by case basis for the retrofit and for the BEC schemes. That's basically it. Again, you see our details at the end. Thanks everyone for listening. And again, we partner with Middle and Warmer Homes, who cover the BEC and the retrofit scheme in the Midland area. Thanks, Mel.
Thanks very much, Neil. And once again, there, again, we had asked Neil for an example with a heat pump. Now you could see in that example the similar approach to the first house. You're dealing with fabric first, and then when it came to the heating system, the heat pump, the jump in the BER uplift was significant there from C3 to A2. So it's quite possible that home could have got to a B2 with a condensing oil boiler and a heating controls upgrade. But that's an example that shows you how much the heat pump increases the overall efficiency of the home. But the home has to be right for it. So the heat loss indicator, the information around that there is very important. So we'll move on to our final speaker, and then we'll go to questions. So we have David Flannery here of Super Homes. David, are you there?
I am. Hi, Mel.
Good stuff. So you're going to take control now.
Now I hope you can see something there.
David, could I ask you just to share your screen there, please?
Yeah, is that it?
No, it hasn't come through here on our side. Could you reshare, please? There we go. That should be it.
Okay. Thanks very much for the invitation here today to be part of this, Mel, Paul, and Stevie. Much appreciated. So I'm going to give a little, I suppose, a description of one of our projects, a little bit of background to ourselves in a moment. I suppose when I was asked to give an example of one of our retrofits to an A standard, I instantly thought about more transformational projects where there was an obvious aesthetic improvement. So a house that you would drive by and you would notice either through brand new windows or external wall insulation or various sort of measures, external measures, you would see a house that would be transformed from old to new. And that's great. We have lots of examples of that. And if anyone wants to see them, superhomes.ie. There's plenty of examples there to see that. But I suppose today I wanted maybe to give an example of something a little more understated, where the house isn't being gutted, where in fact there's sensitivities in around by disturbances and so on. The things are in place you want to keep in place, where you've got windows that are of a certain age you don't want to change, where I suppose, in essence, where the job is a little bit trickier, a little bit more bespoke, where you can still get to the A standard without a catch-all type solution. Rather, you use your professional expertise and your contractor's experience to deliver a solution which is the right solution and the most cost-effective solution for that house. So I thought this might be an interesting example. Right, well, that's disappeared. Anyway, Super Homes, maybe to describe a little bit about who we are first off. We are a not-for-profit social enterprise. We've established through Tipperary Energy Agency, which has been implementing energy solutions for homes and businesses for over 20 years. Super Homes is going since about 2015, and in many ways, I suppose we were ahead of the deep retrofit curve that came in 2 years later through the deep retrofit scheme. So we've been doing this a while, and a few hundred houses of all different types throughout the whole country, which demonstrates, I suppose, every different housing typology and every different type of solution to the highest standards. Our key essentials are renewable heating systems such as a heat pump, advanced ventilation, and air tightness. So those two things go hand in hand. Of course, what you need now, and what you always needed, was a fabric first approach as well to make sure that your house was up to a reasonable standard of insulation, which is now, I suppose, best articulated through the heat loss indicator. We work throughout the countryside. My own role within the organisation is one to liaise with customers. So I'm involved in all of these projects from the point of view of working on a technical solution for the customer in a way that they can understand and buy into, and they can see the value for themselves as well. So our team contains also engineers, long experience in retrofit, as well as people responsible for it. So we are a one-stop shop. So what we'd like to do is take a project from inquiry to explaining the process, the potential cost, then further on to survey, speccing out a solution, applying for grants on their behalf, and also to some extent overseeing the works, and at least making sure that they're grant compliant, and eventually the grant is paid out. So our record in terms of no payout for our customers is 100%, and that's the level of involvement we have in a project throughout. So that's a little bit about ourselves. So I suppose it might be worth starting on what our targets actually are. And I know the shorthand, and as people commonly understand it, success in terms of energy efficiency is demonstrated through the BER. And sure, that's true. It's your predicted energy use, and it's ultimately long term. It's the most relevant indicator. But I suppose that's not where we start. So we're looking at a house that is to be retrofitted, no matter what age it is. And people might ask us fairly often, well, like, I've got an old house, will a heat pump work in it? Well, you will, but of course what you need to do is you need to bring it up to modern standards of insulation, and then it'll work perfectly fine. So I would start by saying, I suppose, maybe just throw a little spanner in the works, say that the BER doesn't tell the full story. There are things in around that might be represented on the BER that your experience or investigation will show it's either in excess of the what would be on the BER by way of a backstop, or it might not meet it. And this is I suppose what you're trying to do is to make sure that your retrofit works in practice, not just on paper. And getting both of those things right is key to a successful retrofit. So where we start, we look at a project of the heat loss indicator and see where that is. And what you find, I think, in most cases, with few exceptions, and they are very few, is that when you reach that heat loss indicator, and I'm not saying that that's an easy thing to do, particularly in some of the examples we might talk about in relation to bungalows and so on. When you do reach the heat loss indicator, and you combine that with an air source heat pump, you're almost certain to get to the B2 standard. So we start off with the heat loss indicator. Sometimes, in order to tip yourself into the A, it's simply the addition of solar PV that will get you there. And you can take that then, the solar PV, as an option, and you can weigh it up based on its return on investment, knowing that you've already reached the B2 minimum, and you can take it onto an A3 budget permitting, or if you think it's the right thing to do for yourself. So the key aspects of a successful retrofit are a minimum standard of building fabric insulation, as articulated through the heat loss indicator, addressing air permeability. People often attribute to poor insulation what should be attributed to air permeability and drafts, and that's key to. It's the tricky part of a retrofit, but it's the essential part. And just, I suppose, chiming what Neil mentioned earlier about an air tightness test, it's certainly recommended in cases where there appears to be drafts in place, where there might be a timber frame without a modern membrane, and so on. And once you reach that level of air permeability, that air tightness of 5 air changes, which is our usual target, and you're looking at an advanced ventilation system to make sure your house performs in a healthy fashion. High efficiency primary heating source such as a heat pump. And key is that it's systemic. So you're thinking about all of the parts of this retrofit together, how they affect each other. So you're thinking about your house as a system. You're trying to do so in the most cost-effective way possible. And sometimes that's where the challenge lies. And when you do that, you result in a high standard BER, and in the case I'm going to show, that's an A3. So this is a house in Tipperary, built in 1999. Nothing hugely remarkable about it. There's tens of thousands of these houses throughout the countryside. Built through the building codes 98 onwards. The pre-works read of 212 kilowatt hours per metre squared. So a C3, bang in the middle of the C3. Not unremarkable in itself for an older boiler. But the air tightness was certainly something which raised eyebrows at 14 air changes per hour, which is very similar to an old 1960s bungalow. That's very leaky with all windows. So that was something that I suppose came to the fore immediately as something that would need to be addressed in order to make the project make the project work in practice to reduce those drafts. You can see on the right hand side where it was delivered. So an A3, 66 kilowatt hours per metre squared per year, and an air change figure of 4.8. Our actual target in terms of the heat loss indicator and the B target was 7 air changes. 5 air changes is what we went for and got in order to make the case for a demand control ventilation system, which was. So just an example, an overview of this house shows, I suppose, that the low-hanging fruit had been eaten in terms of energy measures. So the walls were pumped with bonded bead already. The roof is insulated 250 mils of fiberglass, not leaving a huge amount of improvement possible there. And the windows have been replaced, were double glazed PVC frame and were in good condition. The floors are solid throughout, so no suspended floor that you could address point of view of reducing the air permeability. So I suppose the principle that we'd have in relation to floors is not to take up floors if at all possible, and not to say people don't choose ultimately to take up the floor and put underfloor heating, and that's fine. But I suppose it would be the last thing on the list that we would recommend in order to reach a heat loss indicator, because we have the high cost and a lot of disturbance and isn't for everyone. As we sort of look to do nationwide 500,000 homes to a B2 standard, we really have to find ways that costs can be kept down and disturbances minimized and the speed of retrofit time reduced. So the homeowner, no matter that these measures have been carried out and some improvements were found, that the homeowner was still finding that the house is losing heat quickly when the heating is turned off. I'll explain why in a moment. Drafts in several areas and high heating bills. So let's go back up to the picture here. So you can see my cursor there on the screen, I hope. Okay. So the key areas here, I suppose, are the garage, which has a very leaky garage door on it. The party wall between the utility room and the garage, there's a door in it that was an internal grade door. At the back of the garage then, the utility room is at the back of the garage and the kitchen to the right hand side. You have bay windows here, which on the deep software for its age will show 50 mil of insulation in it. We rather suspected, and the contractor in particular was a very, very diligent in how they approached it, suspected that it wasn't the case. And further investigation showed that there was nothing in there at all. So again, it's one of these examples where you could upgrade and on paper achieve a certain figure, knowing, I suppose, through experience and through investigation, in actual fact, the house isn't going to perform according to that result. The windows already in meant that, the windows in reasonable condition of less than 20 years old would mean that it's not something that you want to change, and not at the end of life. You want to retain them if at all possible. Again, it's one of these things that removes from you the catch-all response, which would be to change the windows, seal them in properly while doing so. Be something like external wall insulation, which would be act as a coverall for any or some of the air leakages. but certainly in terms of improving the thermal values of the wall. So at the top left picture, you can see the internal grade door between the utility room and the utility room and the garage, which is very leaky. So you've got cavity pumped walls, and that's also the case in between the walls of the utility room, kitchen, into the garage. But because the drafts were so extreme coming through the garage door, that wall was very cold. There was a massive drop in temperature anytime the heating was turned off, and the rooms in particular, that felt that drop in temperature in particular, were the rooms that were adjoining the garage. So the solution here was PIR board across this entire wall with a wood fibre finish on it, and a high quality external grade door put on to replace the one you see in front of you there. Open fireplaces then permanently blocked up to reduce drafts. Top right, you can see a picture then of the application of silicone in around by the windows to reduce the draft levels there. Not all windows that would have been put in at that date and for many years afterwards would have been put in with membrane or expanding foam and would be very leaky, not just there but also under the window boards as well. So the picture you can see from the cursor here then of the bay window that I alluded to earlier on, with no insulation in it. And so the tiles were removed from the top of this to reveal zero insulation within. Rigid insulation board put in between the joists, caulked in around by the edges where the timbers reached met the masonry. Rigid insulation between the joists, insulation laid on top of the rigid insulation, and then after that, then the tiles reinstated in that, acting as a the caulk acting as a membrane from an airtightness point of view. On the bottom right, and again, our contractor in this project, Metro Developments, would have had a lot of experience of this type of house. So in around the years 2000, houses were a common feature is on the first floor where the joists meet where perforate the wall into the cavity, no sealant there whatsoever. So what you have is even where the cavity is pumped, what you have is a thermal looping happening coming in through the cavity, through the joists, and distributing essentially through the house. So what had to be carried out in this instance was the floors lifted and expanding foam then applied in and around by the joists where it met the wall. The flooring put down back on top afterwards, and considered sealed thereafter. So, on a more detailed level, thermally insulate the garage, internal wall insulation to internal garage walls, replace the existing drafty internal door between garage and utility with a new energy loss door, replace existing front and back doors with energy loss doors, low energy doors, lock the chimney fire in the living room, remove the tiles externally over the bay window, sealant applied at edges, insulation applied between and over joists and tiles reinstated, sealant applied between window and window boards and between wall and window boards, and the first floor floorboards lifted as I explained there. And I suppose on top of that, all penetrations in the building fabric then sealed any works that were carried out in terms of plumbing for that to be diligently installed as well. So use diligence in by the new work and then patching up in around by obvious holes in the fabric to bring that airtightness figure down. Once this was achieved and once the fabric was improved to that extent, then you've reached the heat loss indicator. You've created a house which you can then put in a heat pump and it can work effectively. Your airtightness is at a standard where demand control ventilation can be installed. For anyone not familiar with that technology, I suppose it might be best described as a hybrid between mechanical heat recovery and natural ventilation, where there is an active ventilation in the moisture areas such as the kitchen and the bathroom, and then the existing venting used for the remainder of the rooms, but there is a moisture strip, a unit put in with a moisture strip which controls to some extent on a low-tech sense then the ventilation in those rooms. So for this project, we also changed the vast majority of the radiators, and I suppose this is to reinforce the point. A good installation and a good upgrade to a standard should deliver you a very successful heating system. A heat loss calculation is carried out on each of the rooms in order to spec a heat pump, but radiators then for each of those rooms that is the right size and that's the right carrying capacity for each of those rooms. A new heat pump compatible insulated hot water cylinder, and smaller measures like low energy light bulbs installed throughout. So I wanted to give an example of a house where you don't have a free roam, where you really have to work with what is there, where you can't go for a catch-all solution such as external wall insulation or triple glazed windows just to be extra safe, where you're not necessarily doing something just to reach the targets, but rather you're doing something that is in the best interest of the house. That's the right thing to do. It's the most cost-effective thing to do, where all the measures make sense. And I wanted to give an example of something which demonstrates the skills and experience of retrofit professionals in bringing about the bespoke solution for that house. I think that's the challenge that we face through our ambitious targets to retrofit 500,000 homes to B2 standard. Is that they're not all going to be glamorous projects, and you're not going to have the opportunity to go to a house in every instance. We're going to get into a lot of houses of the era of this house where you're going to have a very bespoke solution and one that keeps the cost down to a minimum while at the same time delivering a very successful retrofit and efficient home. So in conclusion, when you're trying to get to an A3, every aspect of the house needs to be assessed. Cannot exclude certain areas simply on the basis that it might appear okay on paper, and everything needs to be measured, of course, on paper. So the key aspects of a successful retrofit are the minimum standard of building fabric insulation, addressing air permeability. In this case, it was brought down from 14 air changes to less than 5 air changes. Advanced ventilation, so that your house is healthy. So you're not just enjoying the efficiency gains of the retrofit, but your house is a more comfortable and healthier place to be as a result. And a high efficiency primary heating system such as a heat pump. And once you've done this and you've achieved the heat loss and you've reached that level of air tightness, well, you've put 80% of the work and cost into making a heat pump work. So the obvious thing to do at that point is to put the heat pump in. And again, finally, systemic and cost effective. So something that works for the house and so it is and from what you can demonstrate very clearly both through study, research, and through, in particular, the experience of the homeowner, that it's very effective. So thank you very much today.
Okay, thanks very much, David. I will bring back. Okay, so yeah, thanks very much to Pat, Neil, and David for that. That was a nice final example there. You know, there's a lot of bespoke information to be taken into account, and it shows the importance of getting that kind of technical advice rather than deciding on generic measures in a lot of cases, and probably in all cases. So we'll move on to the questions. Stevie, do you want to pick some? I haven't been able to read through them as much as yourself.
Yeah, no problem. There's been lots of questions, and even the interest of the amount of people that registered and that are attending. So there's loads and loads of questions to go through. What I'm going to try and do is pick questions that kind of cover off topics that the presenters can answer when it comes to maybe specific things about specific houses, it's probably best to contact either one of the three lads that have presented today, and I think Paul is after putting up their details there, or their websites, or else indeed look on the SEAI website and try and search for a project coordinator to try and answer some of those questions. So I might start with Pat Lavin. Are you still there, Pat?
Yeah, I'm here.
Yeah, how's it going? So just one of the first questions in there is about old stone houses and maybe some of the external wall insulation considerations when it comes to old stone houses. If you could give us maybe just some brief considerations that people should consider.
Yeah, if you're looking at old stone houses, you have to look at the breathability that's required for that particular wall. So we would do a lot of older houses, be they mass concrete or stone. That's what we have to decide first of all. So obviously you go out, you measure the house, you look what's in it. Now, if it's a stone house, it more than likely will require a breathable system, where a mass concrete house will not. The stone house will require extra insulation to be done by a rock wool system rather than EPS polystyrene. So the rock wool is glued onto the outside of the building with a breathable adhesive, and then over the rock wool, you put your base coat, which again is breathable, and your final coat, which would be the aesthetics, which would give it the look. That too obviously needs to be breathable. So in that case, you will be looking at a mineral finish and a paint, or else a silicat finish, which is a pre-colored finish, which is also breathable. So that is in a case where you have lime render and lime plaster. So if the stone wall is put together with, let's say, a sand and cement type mortar, and it's plastered externally with sand and cement, it's not breathable, or it doesn't require a breathable product. Okay.
That sounds, Pat, thanks very much for that, much appreciated. There's lots of questions about the different costs of the different case studies, I suppose, that you're after going through. So that might be something that we'll ask each of the presenters to provide more information about, or even myself, Mel or Paul will try and find some case studies. It's very difficult to cost all these different questions and all these different houses. But maybe for the examples that have been presented today, we might look at providing those to some of the to the attendees today. So we'll speak with the presenters about that. Sorry, Mel, go ahead.
Just before you move on there, Pat, one of the questions, I suppose, in relation to that solution for stone wall houses is that solution eligible for SEAI grant funding?
That solution is an SEAI approved solution, so therefore it is eligible for funding under the grant applications. Yes.
Okay, thanks, Pat.
We have carried that out on a number of buildings. But to give you a percentage, I suppose, we've done over 800 external insulation jobs ourselves, or else our subcontractors. And of that particular system would be maybe 1 or 2%. So it's not something that's done on a regular basis. And I think most of the reason for that is the cost. So it will be at least 60% more expensive to put a breathable system in place than a standard system.
Okay. Here's a question. It's not too technical. Neil Walsh, I'll ask you maybe to answer this, but I think it's a common thing when people start looking at their homes and trying to figure out what should I do, how much is it going to cost, and there's always talk of BERs and doing a BER assessment. And the question is, what's the difference between a BER assessment and an actual energy audit? And I suppose, what are the stages then that a homeowner should go through in helping them to inform a decision about the investment they'll make? Is that okay, Neil? Okay, we might have lost Neil.
You can maybe feel that one if.
Yeah, David, if you want to take that one, please.
Yeah, I suppose a BER assessment is going to, I suppose, give you from a template an idea about what your clear idea about what your BER is. You know, the question people ask then is, well, what do I do next? That's fine. So I suppose this is every stage in the retrofit journey. What you find is there's points at which people need to move from one service provider to the next, unless they look at something perhaps which is about that one stop where you once you've received a BER, and your next question is going to be, well, that's fine. Now, what do I do about it now I know my BER? Of course, the next thing is once you get some good independent advice about what you should do. Your next question, then, of course, if you're interested, is, well, who's going to do it for me? And these things are very much linked. So the closer you can bring all these together, so you have a trusted professional that can take you through every single stage. So if you do decide to proceed, is that there's someone there looking after you from the point of view of making sure that the right contractor is chosen, from the point of view of making sure that the job is done to a high standard and is completed and certified in accordance with your post-works BER, which should be what emerges from the process if it's carried out well. So good advice is imperative, but it needs to be supported the whole way through the process.
Okay, David, thanks for that.
Just add to that, Stevie. In some cases, if a BER gets a call and a BER assessor gets a call or an email says somebody wants a BER cert, it may be just for somebody who is selling or renting a home. And in that case, they're only going to get that nice coloured cert and the very technical advisory report at the back. And it'll go into a file and go to an estate agent, and that's it. The job is done because it's a legal requirement. If you're engaging a BER assessor and you want to know what to get done with your home, tell them that, and then that's where you get the energy audit as opposed to just a BER cert. And that's where you'll get that more readable advice and user-friendly advice. Okay, thanks, Stevie.
Okay, next question. Don't all jump at once now when I ask this. There's a couple of questions coming in about foam insulation, and I suppose the thinking around using foam insulation for attic conversions rather than using solid insulation in between the rafters. And then another question about using foam insulation for underfloor insulation. So, Neil, are you there? I'll give you an opportunity to answer that question there.
I got the easy one.
Oh, is that the easy one? Yeah.
Yeah. The foam in an attic conversion, in my opinion, acts as a brilliant air tightness membrane. That if you're insulating between your wall plate all the way up to your ridge board, that it gives both level of insulation and air tightness. It's really designed to be installed from the wall plate all the way along the ridge of the rafter to the very top point of the attic, which is very hard to retrofit correctly without getting in at the sloping section. So again, it's some people insulate and use a foam between the wall plate and the purline, which would be the top of the stud wall. Now I know I'm getting into different areas of an attic, but it's the air movement under the floor from the external vents seems to be the major problem in a retrofit. And a converted attic or a dormer. The dormers were built readily in the 90s and they're impossible to make airtight. So the spray foam in that case will get that air tightness in the air tightness problem sorted, and there still may be insulation that needs to be fitted on the flat sections of attics and the stud walls or the knee walls going into the attic. New build dormers mainly have air tightness fitted, or the foam is fitted as part of the new build, and that means that that air infiltration is not coming in from your external ventilation in your soffits or your slate or tile vents. In terms of putting foam in an old suspended floor, if it's breathable and a contractor agrees to do it or agrees to work it, it's a very hard thing to get done and get done right. If you're going to that cost, my recommendation would be to take up the floor, fill it up, and insulate it and screed it, because getting a contractor to go taking off floorboards, foaming it, and putting down floorboards again you'd be going a long way towards the cost of doing the right job, which would be eliminating the suspended floor completely.
Okay, Neil, thanks for that. Some questions here around double glazing and triple glazing, which is the preferred, and also a good question, I suppose, is it possible to install double glazing on the south-facing side of your house only? Is that allowed? Is it eligible for grants? So, Pat Lavin, I might come to you first to give your opinion on double and triple glazing, and then also we'll go to David about that as well. But Pat, sorry, if you could have a go at answering that first, please.
Yeah, no problem. I suppose rather than looking at double or triple glazing, you have to look at the thermal performance of the individual window. So when you're looking at the windows, you may have a double glazing window which has a very good thermal performance, and the cost to increase that to triple glazing may have a very, very significant payback period. So if it's a very good double glazing unit and it's a lot cheaper than a triple glazing unit, well, you know, I would be of the opinion that you'd stick with your double glazing unit in that case. You do have to look at specifically the overall U value of the window, not the elemental U value of the window. So you look at the window as a whole, as opposed to just the glass. So the triple glazing is an element of it, but you also have to look at the frame. So that's how you get your overall U value with the combination of both of them. In terms of going double glazing versus triple glazing on a south elevation, we have done something like that, but it was on a deeper retrofit building, and it's currently in its second year, and we're using an actual section between on the south elevation to catch some heat and putting it through the heat recovery ventilation system. So we're trialing that at the moment with it's called an orangery, where you have two sets of glass, one inside the other with maybe a 2 meter space between them, and you're using the solar gain for that, putting it through the heat recovery to boost the heating system. But that's the only experience we would have of that particular type of setup.
Okay, thanks, Pat. David, do you have anything to say about windows there? If not, we can move on to other questions.
Not much in addition to Neil, only to say, I suppose, that when you start thinking about things and measures in isolation from each other, I suppose that's it's not. You can look at the difference between a double glaze and triple glaze, and you can see the U value that's going to be an improvement. So the answer to the question, of course, is there is a better U value when it comes to triple glaze over double glaze, generally speaking. It will be better, but whether that's the place to start, I don't know. You know, so you try not to look at these things in isolation from each other. Rather, you look at the interplay of all of your measures and your overall values to see where the best place to start is. And again, if triple glaze might be better than double glaze, and 0.8 might be better than 1.4, but are you going to go and change reasonably recent windows in order to derive that sort of very minor level of improvement? The answer to that would be not cost effectively. But again, I suppose it's just to think about things from a whole house point of view, rather from just the windows and the individual measures.
Okay, cheers. Neil, a question here about do you have to pump the cavity wall with beads prior to installing your external wall insulation? Is that required, or is it a misconception?
It's required, because if you can imagine, the heat is escaping through the internal leaf and into the cavity. That cavity is an unventilated, or a ventilated space, I should say. So the air is moving in that cavity. So if your heat escapes through your internal leaf and gets into the cavity in effect is a wind tunnel, and it's constantly moving. And wherever there's an escape route, the air will get out, the heat will get out. So Then you go to your external leaf of blockwork, and then your external insulation. So your heat will actually never reach your external insulation if it enters the cavity. So that's why the requirement is to pump the cavity with bonded bead first before you install external insulation.
Okay, Neil, that's great, thanks. Question here about, and I have a preference here because we handle a lot of the island communities in the region, the border and west, and there's a good question here about external wall insulation for homes on islands and the impact of that on salt water, and that can even be homes that are on the coastline as well. So, Pat, maybe I'll ask you, any considerations there, or is there anything that can be done about that, or does it degrade the external wall insulation if there's salt water ingress or anything like that?
Yeah, so every particular job you look at for external insulation, you have to look at all the factors, and that would be one factor, which is exposure to coastal locations. In that case, you design into the system extra base coat, which is the coat that goes over the insulation, and you would also be putting on a silicone render finish. So the silicone render is tested and it is approved for use within coastal locations. So that will be the scenario with that. And again, you look at the homeowner's manual to make sure that you carry out the maintenance every year that doesn't allow for the system to degrade. So people are under the false illusion that once you put on external insulation and you put the render system on over it, that you never need to go near it again, that it's, you know, it's there for infinity. It's not. Every year you need to go around and check all the areas where the system meets another element, be the window sills, the windows, your soffit, the footpath, and make sure you find any little imperfections and you repair them at that stage. I suppose the analogy we use for it is like if you left your car for 8 or 10 years parked outside your house, it will go green. So the same scenario is with this. You have to maintain the system in accordance with the manufacturer's instructions. But those works are very minimal, very little. But again, you do need to do it.
Great, thanks, Pat. So yeah, there's lots of different technical questions around moisture risks, capillary ingress, lots of questions about grant amounts available. So I've tried to send a few links there and reply to people. There are lots of different types of grants available from SEAI. So unfortunately, it means kind of going into each of them and having a look and seeing if it's the right one for you or your community or your business. Mel, I might ask you to answer this one, and it's about the people are referring to the retrofit scheme, and I think they're referring to the National Housing Retrofit Scheme. And I suppose how SECs can take part in that, and then also, is there a closing date? I put on the website there as this webinar has been going on, and it says there's an indicative deadline of the 31st of January. So nice and not definitive there. So can you go into that? And I suppose maybe more longer term, this is the first year of the National Housing Retrofit Scheme. We're hoping that it's going to become a multi-annual thing that doesn't have deadlines, and that you will be able to work with one-stop shops. Yeah, okay, there's a lot to go into there, but the National Housing Retrofit Strategy or Scheme is just, it's a fancy term for the BEC as we knew it, but where you can only have housing, where you can just put in a project with housing. In those schemes, they're the big schemes where you make an application for a lot of projects in one go. From an individual homeowner's point of view, or even an individual business point of view, you need to contact a project coordinator. So on the SEAI website, and we'll send out links with the emails that we send out to everyone on this, you'll see a list of project coordinators. And that's not an exclusive list, that's a list that they update it from time to time. And you can contact them if you're interested in it. Was there something else to that, Stevie? Oh, in terms of the time frame at the moment, yes, the
for the last few years, the way that scheme, or the BEC scheme, or community grant scheme as it's known, has worked is that it opens for application in November, December, and then closes in January. And those grants then, once they're approved, they have to be used in that year, usually by the first or second Friday in October, and the works have to be complete. This year, the reason they're saying there's an indicative closing date by the 31st of January is that so far from the applications that SEAI have received, not all of the total grant funding available this year has been allocated. So it's likely that they may extend that deadline or open it up again for application later in the year, subject to whatever budget is available. But if you're interested, the best thing to do is contact one of those project coordinators or contact one of the speakers that are here today. Now, I know that a lot of people have been asking about costs, and I know it's frustrating to be on these webinars and for us to try and dodge that. So I'm going to do a little exercise here. It's a bit of an experiment. I'm going to read out what I think a typical cost is for different ranges of upgrades. And I'm going to ask Pat, Neil and David to say if I'm high or low, or around about right. Okay? You okay with that? All right. So to get a BER, you're typically looking somewhere between 200 and 400 euros. That seem reasonable?
Yeah.
Okay. That'll depend on, you know, what kind of information you want in there. If you're doing your attic insulation, your typical investment is about 1,000 euros. Okay. Anyone think I'm low or high there?
Depends on the size of the attic.
Yeah, exactly. Yeah. So there's no such thing as a typical home, but let's say there was. Now we get into the bigger stuff. The cavity wall insulation, between 1,200 and 2,000. Again, depending on the size of the home. That's the pumped cavity. So it is a very cost-effective solution, as is attic insulation. They're both very cost-effective.
Mel.
Yeah.
Mel, it might be just worth saying these are obviously the costs without any grant support.
Yes, this is the cost before any grant support. Okay. For internal wall insulation, so this is the dry lining. Again, this would be this would be a big range, but somewhere between 10,000 and 15,000. Again, that's going to vary a lot, and it could go well outside that range. That'd be okay. So I'm not doing anything ludicrous as yet. Now, external wall insulation. So this is the wrap. Let's say we're not talking about a stone house. We're talking about a house that can be done with the standard EPS insulation. So somewhere between 15 and 25,000. Again, talking around, you know, the house size, and there's a lot of detail to be considered. The number of windows, the reveals, the number of windowsills, all of that adds cost. Am I somewhere in the ballpark there? Yeah.
That's it. You're close.
Okay. Right. External doors and windows, there's no point in me saying anything there, because it really depends on how many they are, you know, what sort of state the walls are in, what it's going to take to fit it. It's usually a considerable investment. It's usually, you know, if you're looking at doing all your external doors and windows, it's probably 20 grand or more if you're doing them all in one go. And that's if, you know, if they all have to be done. So moving on then to the heat pumps. Now, the heat pump, somewhere between 9 and 12,000. You may have additional costs then if you need a lot of, if you need a specific ventilation put in, and that could be another 1,500 to 3,000.
Yeah.
Same reason. Okay.
Yeah.
So they are the more they're the external wall insulation, the internal wall insulation, and the heat pumps are the more costly elements you'll be considering. If you haven't done anything with your home, start with the attic, look at the cavity walls if you have them, do your own draft proofing if you can, and then, you know, look at heating controls before you look at perhaps at the heating system, and that would be the way to take this on. But if you look through the presentation when you sent it out and you see the way the measures that were taken on board to start with, and the way Neil has shown the kind of uplift you can get for each measure, that's a reasonable progression to look at any home. Okay.
Mel,
Okay, just to clarify, that wasn't a quotation to anyone.
Mel, one other question there that is of relevance, I think, when talking about all these costs and the different grant amounts, and we might leave this open to David and Neil and Pat and even yourself to try and answer it. Do you see the grant amounts increasing over the coming years in order to encourage more people, or is the methodology now being employed, these large-scale retrofits, just aimed at getting economies of scale? The grant amounts stay the same, but we just aim for economies of scale, doing large-scale retrofits, and that's how you bring your prices down? Or can we expect higher grant amounts, say, over the next 5 years?
Well, I think people will be best advised to plan on the basis that the grants are as high now as they're going to be. I think the way things are going internationally, and I think there's wins of it here, is that the burden on the exchequer at the high grant rates, at the volume we're talking about, is huge. And over time, what we'll possibly see is a movement away from some element of grant funding towards low-cost finance, which will suit other people better in some ways as well. But for most people, I think the higher grant is what they would rather go for. When the grants were even higher 2 years ago, I was asked a similar question: are they likely to go up? And of course, they haven't. And I think people, if they combine the fact that it's unlikely to go up, much more likely to come down, and in the meantime they can arrive their energy savings quickly. And if they're in a position to act, they should do so now, because it makes sense to do it.
Neil or Pat, do you have any take on that? Probably similar to David.
I'd be the same. I don't think they're going to increase by any significant amount. The grant is there, I suppose, at the start to push awareness towards people that this work can be done in your house. This work can, and it is now grant aided. And as time goes by, they will lessen and lessen the amount of grant money that's available towards these different measures. And they will be hoping that people will be getting on board anyway and getting the work done without the, I suppose, the carrot of a grant to get the work started in the first place.
Okay, thanks.
Yeah, I would be of the same opinion on that point. The only other thing I'd say on that is, things will only get more expensive. Labour will get dearer, materials will get dearer. So, I don't know, will that 35% remain a real 35% of what people are looking towards getting done? And the other big question we have is the skilled labour force to carry out the works. So that's where I think we will struggle a lot with a greater uptake. What we always try and do is local supply chain. I mean, we get our windows manufactured locally. We try and upskill local guys to do the work locally, but that's where I think there will be a struggle if the uptake mushrooms or grows as substantially as we think it will, because we just don't have the skilled workforce in Ireland to get the number of houses done that they're talking about getting done. And again, that goes back to supply and demand. That'll drive the price of labour up. So that's my opinion on it.
That's great. I'll leave it to you to close up.
Okay. Yeah, just one point that David raised there was around lower cost finance. So while the grants might stay the same, there are more finance solutions coming to the market. So credit unions are offering loans for home upgrades. Some mortgage lenders are providing green mortgages now, or top-ups to mortgages that you can use to finance the net cost you have for home upgrades. So look, first of all, I'd like to thank again the speakers. So Pat Lavin of EcoSmart, Neil Walsh of First Rate Energy Services, and David Flannery of Super Homes. And I'd like to thank my colleagues Stevie Donnelly and Paul McNamara. Paul's been quite anonymous there in the background, but without him this really wouldn't be happening. And thank everyone who's attended. I know that there's been some difficulties with people logging in. It happens with all of our webinars, but we will be, this is being recorded. We'll email all those who registered with a link to the video and some follow-up notes that we mentioned during the presentation. So with that, we'll leave it there, and thanks once again for attending. Thank you.